Okay, 10.2 is using combinations and the binomial theorem. Okay, we're gonna split this lesson into 2 days because the second part of it gets a little tricky sometimes. But the first part's pretty simple. Okay, combinations of n objects taken r at a time. The number of combinations of r objects taken from a group of n distinct objects is denoted by NCR and is given by this formula. And the formula is n factorial over n minus r factorial times r factorial. This is when order matters. Okay, yesterday we just did it, it didn't matter what order the letters were in, if they repeat it, it's fine, but it didn't matter, the order. When you have a combination, your order does matter, okay? That's the difference between the two of them. So we're gonna take a look at a few problems. A standard deck of 52 playing cards has 4 suits, right? You have spades, hearts, diamonds, and clubs, okay? And each have 13 different cards in the suit, okay? You have a 2 through 10, which are number cards, you have an ace, and then you have 3 face cards, correct? Okay. If the order in which the cards are dealt is not important, how many different 5-card hands are possible? Okay, so if the order, well, actually, this is worded weird.
That is weird. It is.
Well,
Okay, so here's the deal. You want 5-card hands, right? How many different 5-card hands are possible? So, how many cards are in a deck?
52.
52. And how many are you looking for?
5.
5. So we're going to make a combination out of this, 52C5. Here's why. When I deal out a card, can I deal that card out again?
No.
No, it's already been dealt, right? So it's like taking it away, like we talked yesterday, when things repeated in license plates or couldn't repeat, okay? This is when it can't repeat. So if I do 52C5, that essentially is saying that I am doing this. 52 factorial over 52 minus 5 factorial times 5 factorial. Okay, that's what I'm actually putting into my calculator.
A big number.
So watch this, we're gonna do it in our calculator in a second, but I wanna show you the math behind it. What's 52 minus 5?
47.
47, so you get 47 factorial times 5 factorial. Now, look at this. If I take 52 times 51 times 50, 49, 48, 47, right? Okay,
Yeah.
and I kept, let's say I kept going.
Oh, and then you would cancel with the.
The 47 and down cancels that and down, yes?
Oh.
Okay, but then you still have that 5 factorial on bottom, right?
Yes.
Okay, I still have times 5 factorial, and 5 factorial is 5 times 4 times 3 times 2 times 1, right?
Yeah.
So I would still cancel more up top, because 5 can go into things, 4 can go into things, right? 3 can go into things, 2 and 1, okay? But that's what's happening, is basically, all these numbers down are getting canceled out, okay? So what do you get when you put 52C5 in your calculator, and how do you get to that again?
Well, what the answer you want? Well, you hit the probability button or whatever you want.
Yeah, hit the probability button, good. And then, of course, you're gonna choose the one that says NCR
Yeah.
this time. And you get 52 NCR5, and that gives you, hopefully, this large number.
2,598,000 times 60.
Good.
That Jason. Stop it right now.
2,598,960 different possible ways to deal 52 cards at a 5-hand card. Now, part B says, and how many 5-card hands are all 5 cards of the same color? Okay, so we gotta do a little thinking for this, and this is where it gets a little tricky, okay? And how many 5-card hands are all 5 cards of the same color? Okay, how many groups have the same color here? 2, okay? So we're gonna start with that. We have 2C1, because I need a card from 2 of the groups, okay? Because I need the same color. Times, how many cards are in those 2 groups?
13.
26 total.
Because there's two groups.
And how many cards did you want?
You wanted 5.
Boom. Okay, so here's how I get this. It says, in how many 5-card hands are all 5 cards of the same color? I say, well, how many groups have the same color? 2. That's where I get that number from. How many colors do I want? 1. Okay, there are 2 different colors. I want one of those colors. Okay? Then I get this part by saying, how many total cards are in the one color?
Okay.
26. Now, how many cards do I want?
5.
5, and that's how I get that math. Does that make sense? So this technically is 2 factorial over 2 minus 1 factorial times 1 factorial, right? And then I multiply that by 26 factorial over 26 minus 5 factorial times 5 factorial. When you multiply those two together in your calculator, what do you actually get?
I don't know yet.
131,560.
Okay, let me double check what I can do. 1 times 26 factorial 5. You said this?
Yes.
Okay. Get 131,560, okay? Because when you do 2 and then you do combination 1, you get the number 2. See, this, it works out this way because this is 2 factorial over 1 factorial times 1 factorial, right? So the ones cancel at the top and you just get 2.
Does it matter, like, can we just do, like, do we have to show it on paper, or do can we just use it on our calculator?
Okay, here's the deal. I need you to write this down
Okay.
so that I know what math you did in your calculator, okay? If for some reason they tell you on a couple of them, they tell you to just like show what that would look like in fraction form, then you would write it this way.
Okay.
But I definitely need this, cause I don't know, I don't have a freaking idea what you're doing if I don't even
Are
see
these
that.
all gonna be word problems?
Oh,
Oh, no.
I kind of figured it all work on it's because probability.
She said, I need something to do, and last night the equations were like that.
okay. When finding the number of ways both an event A and an event B occur, you need to multiply, as in part B of example 1, what we just did. When finding the number of ways that event A or event B occur, you add instead of multiplying. So, when it says, how do both of these events and is the key word that says multiply. If it says or, you're adding.
Yeah.
Okay? So it says William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, 10 are tragedies. How many different sets of exactly, okay, see that word exactly, how many different sets of exactly 2 comedies and 1 tragedy can you read? So tell me what you know so far.
He wrote 38 plays in total.
Okay,
18 comedies and 10 tragedies.
okay, we're looking for tragedies and comedies right now, so we know 18 comedies, 10 tragedies.
Yes.
So how would I set that up if I want it to be exactly 2 comedies and 1 tragedy?
Will be 18C10.
Not 18C10, 18C, how many comedies?
Oh, 2.
Good. And then am I multiplying or am I adding these?
Multiply.
Multiplying. And then what do I have?
Then you have
10 and 10C1.
Beautiful, 10C1. Now, tell me what we get.
Oh, okay. Alright.
You should-
1,530.
Yep, you should get 1,530. So there are 1,530 combinations you can create off of 2 comedies and 1 tragedy. Okay?
Yeah.
Because it says exactly. Now, this next one's a little trickier, because it says how many different sets of at most. When it says at most, what does that mean?
the highest.
It could be the highest or it could be
No.
Lowest.
or it could be less than that,
Yeah.
right? So it could be the highest or the number after that, or the number
Yeah.
after that, or the number after that. So what do you think we're gonna do there?
You may have permutation.
No, we're gonna still use a combination, because order
Uh,
matters here,
will we do
at most.
38 and then,
So how many different sets at most 3 plays can you read?
will we multiply,
Not multiplying,
the divide, the subtract,
we're gonna add. We're gonna add here, because we're adding, because let's say you could win at most 17 games in a season, okay? Does that mean you have to win 17?
No.
No.
But you could also win what,
16.
16 or 15 or 14? So we have to add all of those options up together to see how many options we have, okay? You want to read how many total plays?
3.
And how many total are there?
38.
So you're gonna have 38 C3, because that's at most how many
Yeah.
you're reading.
That makes sense.
Now what do you have? 38 C,
18?
no,
Two.
2, because at most I'm
Okay.
reading 3. So I can read 3, or I
Oh,
can
and
read
then
2, or I can read what?
1,
1, or I can read
none,
none,
which is exactly what I would've done.
which is,
Mm,
so then, this is what I need now for you, okay? I need this listed out like this, and then I need each of these individually listed as numbers, so that I know what you're doing.
Oh, and then we just.
And then we'll add them, yeah, so 38,
Wow, why is there not a C button?
There is
C3,
a C button technically.
so I'm gonna have 84, 36. This is how I want you to show me work, okay?
Okay.
38,
Oh, it is, it's right there.
Yeah, you just not that Tuesday.
C2, 703,
9,000.
38, C1. Notice how 38, C1, anything with a 1 is gonna come out as that
Yeah,
number. And what do you think 38, C0 is gonna come out as?
0.
yeah.
Yeah.
Totally was not gonna say one.
No, it comes out as the 1.
I was gonna say
She
one.
said no.
I was gonna say one. Only
Okay, so I want this
Fine.
work shown, and then I want you to add it all up for me. 84, 36 plus 703 plus 38 plus 1 should give you 9,178 combinations.
It's a lot of combinations.
Right. So if you want to choose from any of his
Wait, what?
38 things,
9,781.
Yeah, I was
Yeah.
wondering how you guys.
I
So-
got 1,100.
I was like, that's
9,000.
forever.
No, I got- I got, what he got actually,
9,178.
Hang on, let me do it.
unless,
it is 9,178. My dyslexia is kicking in, sorry. My calculator says 9,178. Okay, beautiful. 9,178.
yeah,
So if Mrs. Porter ever asked you, or Mrs.
Zafiro.
Zafiro.
Actually, that's 37.
Because
Actually,
she
said
is,
37.
She
likes
says
her
six.
Shakespeare, right?
Yeah, she does.
She
If
said
she ever
six.
said you have to read 3 of his works out of 38, you would know that technically speaking, none of you should technically read the same amount, should you? The same combinations, correct? Because there are 9,178 combinations.
Except
of
nobody's
that.
gonna read. none
Right,
of
because
her
you all
sisters.
gonna read the same thing and just copy off of the one person that
That's
actually
true.
read.
See, that's how I got into high
Yes.
school, right there.
Yes, sir.
Dude, high school is probably the biggest
Okay,
group.
Projects ever.
subtracting possibilities, okay? Counting problems that involve phrases like at least or at most are sometimes easier to solve by subtracting. Okay? Because here's the deal. This at most was easy because I only needed 3 options, right?
Mm-hmm.
What if I needed 27?
Yeah.
So it would be easier for us to find out by subtracting from 38, 37, 36. You get what I'm saying? Because there'd be less numbers to
Oh.
work with. Than it would be to do it from 27 down. Because I would have 27 numbers there, but if I subtracted, I would only have 10 numbers to work with. So sometimes you want to make it easier on yourself and do the opposite, right? Just like when we do percents of stuff. Like when you find, when you're doing a percent of what is the sale price of this item if it's 88% off? Well, it's easier to figure out what 0.12 times that is than what 0.8 times 88 times that is and subtract it. We work backwards. So you're gonna understand by this because this deals with basketball and it's gonna have more games. During the school year, the girls' basketball team is scheduled to play 12 home games. You want to attend at least 3 of those games. How many different combinations of games can you attend? So do I wanna sit there and do 12C12 plus 12C11 plus 12C10 plus 12C9? No, because that's gonna take all day, right? Okay. But you want to attend how many at least?
12, or 3, my bad.
At least 3.
There's
You wanna
12.
attend,
Buddy?
yeah, you wanna
What's-
attend
okay,
at
how many
least
is you?
3, okay?
Well, I mean, 12 games total, that's not a lot of games.
You wanna attend at least 3, okay? So here's how we're gonna set this up. Okay. That means that
You shut up.
you can't attend 0, you can't attend 1, and you can't attend 2, right?
Because you have to be at least 3.
Because you have to be at least 3. So, I'm gonna start with that. I'm gonna say 12C0 plus 12C1 plus 12C2. I'm putting those in parentheses, because I can't attend that amount of games. Okay?
So we just don't include those, or?
Right, we're gonna subtract them
Oh, okay, from
Okay.
the other
from
12.
this. Now listen,
That's weird.
how many home games are there?
12.
And how many options are there to attend? You either attend or you
No.
don't. So there's 2 options, yes, for each game. So if I do 2 to the 12th, because there are 12 games, there are 2 options, 12 total games, and subtract from it 12C0 plus 12C1 plus 12C2, I will get my answer easier.
Okay.
What's the other way to do it? Like, what's,
The other way to do it is this.
The long method that you're not
Twelve
gonna.
C
I know,
three
Lotto.
plus 12C4 plus 12C5 plus
oh,
12C6 plus.
okay.
We're not gonna do
To
that.
go all the way
Although-
up to
yeah,
12.
yeah, yeah.
Okay, yeah.
So much simpler, yes?
Yeah.
Okay.
You know you're lazy.
So we took
Yes,
the
sir.
option, so there are 4,096 choices, correct? If I
Yeah.
do 2 to the 12. And then we know 12C0 is what?
1,
And we know that 12C1 is what?
12.
12. And then all we need to plug in is 12C2,
I got
66.
66. So then we have 4,096 minus 79, yes?
Mm-hmm.
79. 4,017.
4,017. So you have 4,017 combinations of games you could attend for at least 3 home games.
Okay, so,
It's a lot.
how many games?
Just for 12 games,
Just for
that's
12
a
games.
lot.
Isn't that crazy for 12 games that you have that many options to make? Think about that. Think about what you do in daily life, like the way you come to school. You probably have more than one option of how you could get to school, road-wise, yes?
Yeah.
Okay? Think about how many, over 365 days, how many options that technically is.
Well,
Mm.
I could, yeah, it's a lot. I could either go past that light
Okay.
by
Oh,
Bridgewater and.
I
go there and
think,
cut there.
let me double check. I think this is, yes. I want to stop here today, because we're gonna break this lesson into 2 parts, maybe 3.
Again, I could